Hi guys, this is Math 116, section 2.4. They labeled this section Special Functions and Graphs, but I would have labeled it Getting a Sense for Graphs. There's a whole lot in this section. I'm sort of surprised at how much they jammed into one section. So I will try to distill it for you and let you know what I expect you to do as a result of reading this section. So in general, I want you to be able to match a simple graph to its an equation. So I'm not going to give you anything too crazy on a test, but in general, if you have a graph, you should be able to match it to the equation. You should also be able to sketch a graph if you have a function. So if I give you a function, you should be able to just pencil in some sort of sketch, and you can use your graphing calculator to help you. And I also want you to be able to evaluate a function, that is, take a number and plug it in. So I'm going to go over some examples working on the graphing part of this, and then the evaluating a function, I will do this in a different video. So I'm going to hit these 2 points, matching a simple graph to its equation and just sketching a graph with a couple of tips for you. So here's a couple of things you can use to help you graph functions. One is shifting functions, another one is looking at piecewise functions, and another one is polynomial functions. So I'm going to take these 3 pieces separately. So the first one is shifting functions. But before we shift functions, there's some basic graphs that you're going to need to know in order to be able to shift them. Here, let me pull this up so that you can see my basic graphs. Okay, so this function right here, y equals 3, that is, let me get that out of there, right here, just a straight line. Do you see how that line goes straight across? Y is always equal to 3. There's no x in here. It's just y equals 3. And that's a straight line, a horizontal line at the point y equals 3. That point right there is 3. There's a little 2 and a 4, so that's at the point y equals 3. So if you see a function like this, you should be able to graph it, y equals 3. Or you should be able to graph y equals 4, or any constant. You should be able to graph a line. And lines look like this. We did a whole section on lines in chapter 1. So this is the equation of the line y equals 3x plus 2, and here it is, right? So you have a slope and a y-intercept, and again you recognize it as a line because x is raised to the power of 1. So you should be able to look at an equation like this and recognize that this is the equation of a line, a straight line, not a squiggly line. So here are some other graphs. Y equals x squared. Well, we've been doing parabolas, so you recognize that. Y equals x squared is a parabola. The constant in front of that is a 1, so it opens upward, right? That's like 1 times x squared. So it opens up because it's greater than 0. And another function that you should have a sense for, this Math 116 is sort of a introductory math class, and so if you go into other classes, they're going to assume that you know that y equals x cubed looks like this. It goes like that. So it curves up, then it kind of flattens out, and then it goes straight up like that. That's y equals x cubed. And you could figure this out if you sat with your calculator for a few minutes and typed in a few numbers. You would see this, but it'll be faster if you have a couple of these memorized. Y equals x cubed looks like that. You don't have to memorize a lot of points, just the general shape. Y equals square root of x. So it starts at 0 because you can't have the square root of a negative number, so there's nothing on the negative side. It starts at 0 and just gets a little bit bigger like that. It just kind of gets bigger, but it doesn't get like crazy bigger because you're taking square roots. So it's, it doesn't get bigger exponentially. It's not an exponential function. This one, y equals cube root of x. We can take the cube root of a negative number, so that's down here. It goes down, up, like that. So again, it's sort of a shifted over version of that one, y equals x cubed. Imagine if you tilted this graph, I could probably rotate it, and you would get the y equals cube root of x. Okay, so these are some functions you should just have handy. Now here's a tricky thing about shifting functions, and in some classes we have spent several weeks just on shifting functions, so if this seems very confusing and very rushed, know that you could spend a lot longer on it, but we're just going to kind of dip our toe into shifting functions and move on. Here's the rule. The graph of y equals some function, the function minus h plus k is the graph of this function shifted h units in the x direction and k units in the y direction. So basically the part that's added on here is the y direction, and you're either going plus or minus, up or down, and the part that's inside the parentheses is the x direction. So I think this sentence is quite true, and it's a nice tidy summary, but it's a little bit hard to feel what's happening with that. So here's some examples. If we take the graph y equals x squared plus 4, do you see how the 4 is outside? It's just added on. You have y equals x squared, you're just adding on 4, so that means it's shifted, the 4 is shifted in the y direction, so it's going up. Let me give you this one. Y equals x squared, looks like that. If I say x squared, make sure I'm doing it here, plus 4, it goes up. Did you see it hop up? Did you see? Did you see? I'll do it again. This is y equals x squared, like that. And if you add 4 plus 4, it goes up in the y direction. So it's shifting up. So it went up along the y-axis. If you take x squared minus 4, you're going down. Going down, my friends. Minus 4. You want to see it go down? Sorry, the keyboard thing got in the way of the hop, but that's y minus 4. See, it's kind of tacked onto the end. It means it went down along the y-axis, down 4. The x-axis ones are a little bit less intuitive. In this case, here's an example. Y equals parentheses x minus 4 squared. This one is shifted 4 to the right. I will show you that on my graph. So in this case, suppose we have x minus 4 and then everything is squared. Do you see how that shifted over? It's over to the right. And this often confuses students because it's minus 4 right here. So it seems like it would be shifted minus. Doesn't it look like it would be over here? But that's why you think it's going in the direction I'm trying to think. It's going in the direction k, negative. So that's why in this function they say x minus h, because that's the minus h is sort of indicating the x direction. Some people just think about it just goes opposite. So if you take minus, it goes to the right. If you take positive, it goes to the left. Okay, let's do another one. Let's do x plus 4. Let's do this whole thing squared. That goes to the left. So x plus 4 goes to the left. So that's shifting. We're shifting functions. So again, one way you can think of it is x plus 4 is like x minus minus 4. So again, if you always put it in terms of minus something, then you'll be back to sort of the positive and negative. Like that's positive 4, so it went to the right. That's negative 4, so it went to the left. But if there's some clever way you can think to remember these, by all means tell me, or you can write this equation down. You can write some examples down on your note cards. But these are the basic directions for shifting. Here's an example. This is question number 5. We have x plus 4 cubed plus 1. Obviously I could just type it into the graphing calculator, but suppose you don't have this. Here we have this question. X plus 4 cubed plus 1. Right? Let me make sure I had that correct. Plus 4 cubed plus 1. Alright, so the first thing you want to remember is we're shifting the graph of x cubed. So let's go up and make sure we have what x cubed looks like. Haha! Looks like that. X cubed. You see this one right there? Okay. So, here's the graph of x cubed, and for these, it just varies. That is fine with me. So we're going plus 4. Let me start with this one. I always like to start on the outside. It's a little bit easier. So we added 1 on the outside. So this part here, that means we're going up. This is the y direction. We're going up 1. So we're taking our graph and we're shifting it up 1, right? Because that was plus 1 here. And this x plus 4 cubed, this is inside the parentheses. Normally our function would be x cubed, but now we're adding a 4 inside the parentheses, and this is plus 4, so remember that inside the parentheses they go the opposite direction, so this is going to the left. And if you want, you can think of it as x minus minus 4, and then this negative 4 might also tell you that that's going to the left. So we're going 4 to the left. So 1, 2, 3, 4. So that's our spot, and now your function would kind of look like, oops, it should have twisted, it should have crossed over at the point there, which is -4 and 1. And now I shall confirm this for you by plugging it in to my, hey, come on, baby, plugging it into my graphing calculator. My mouse doesn't like this. Okay. X plus 4, but now it's not squared, it's cubed, plus 1. Ta-da! Do you see right there? -4, 1. Awesome! How good do we feel? Pretty good. So if you had a question like this, you'd be looking for a graph that was shifted in this direction. So it's over 4 and up 1. Okay, next question. Still on shifting functions. You can see how you could spend a while with this. Y equals square root of x minus 2. So in this case, again, remind ourselves, what does the square root of x function look like? There, this one. That's the square root of x function. So we have something that starts at 0 and just kind of hops over. And our function is square root of x, this is question 12, minus 2. So if we have a function that looks like this, and we're doing square root of x minus 2, we know this part here is inside the function. So, because it's minus, that means it is going to the right by 2. We're going to be shifted to the right. So our square root function looks like this, like that, and we are shifting it over 1, 2. So our new function, this function here that we're dealing with, is shifted. If you like my straight lines, 1, 2, starts here and goes up like that. And you'll notice there's no other component here, so we're not going up or down in the y direction. So our answer, in case you were wondering if you had to answer this, would be shifted 2, like 2 units to the right. So on your test, I would give you a very basic shifting function question, because these can be sort of tricky. So piecewise functions, this section also covers piecewise functions. It just throws a little bit of everything in there. These are functions that change depending on the value of x. So here's an example of a piecewise function. This is question number 9. So f of x equals x squared if x is greater than 2, and 4 if x is, if x is less than or equal to 2, and 4 if x is greater than 2. Okay? So this function, the graph of it, is going to have a gap in it. So here's our graph. Part of the reason I graph by hand is so that you guys will feel better about your hand graphing. So this is 1, 2. So the function for x squared looks like this, right? It's a parabola. I'm going back to the function x squared and then 4. So it's a parabola, but when we get to 2, a miracle occurs. Nope, it stops, there's a little hole there, and then the function, so we think at x squared, when x is 2, that's 2 squared, so that equals 4. So that point there is going to be 4. And normally the parabola would just keep going, but they're saying in this case, when it hits x equals 2, when it's greater than 2, it's 4 from that point on. From that moment on, forever and ever, it's always 4. So that should be a straight line. I'm just not able to really draw it. So that's what this function looks like. And there's a closed circle there. It's a parabola, and then it closes over x equals 2, like that. So that is piecewise functions. They kind of look like this. And the last thing I wanted to cover was polynomial functions. So here's some examples of polynomial functions. It's any function that has these integers in the x or y variable. So you could have x to the 5th, you could have x squared. What you can't have, not a polynomial, are radicals like this cube root. You can't have x to the 1/3. You can't have fancy fractions. So you basically are just sticking with these polynomial functions. So it's anything, raised to the 5th, to the 6th. As long as this exponent is a whole number, an integer, then you're going to have a polynomial function. And the reason we talk about polynomial functions is they have this nice graphing property that a polynomial function can have at most n minus 1 turning points, where n is the highest exponent, like that. So in this case, suppose you had this graph right here, question number 15. How many turning points, and you had this question, this graph, y equals x cubed minus x can have at most blank turning, all right, finish that out, points. Well, in this case, this is a polynomial function because there's no radicals or square roots. 3 is the highest exponent, so you subtract 1, so 3 minus 1 is 2. So the answer is it can have at most 2 turning points. Here's another example of using this. So there's question number 13 has a different graph. I didn't know exactly what the function was, but it says decide if the graph below is a cubic, like a 3rd degree, or quadratic, 4th degree function. Or sorry, quartic, not quadratic. I was thinking quadratic would be 2, quartic, 4th degree function. So look at this function. How many turning points does it have? There's 1 turning point, 2 turning points. It has 2 turning points. So that tells us, 2 turning points, that it can be a 3rd degree function. So it's probably a 3rd degree function because it has 2 turning points. So that's how you would answer that question. And that is actually, right here is the function, 3rd degree. So that's how I put it in the graph. So this was a lot to cover, and I'm not quite done yet. I'm going to do the rest in another video. But again, I want you to be able to match a simple graph to its equation and be able to sketch a graph given the function. And we covered shifting functions, piecewise functions, and polynomial functions, and the number of turning points in this video. This is a lot, so get your graphing calculators handy and make sure they can help you.